Okay, this is a picture of table salt, and we're going to talk about periodic trends on the periodic table. I really love this topic, so we'll see questions about this. This photograph made a pattern of the centers of the and how this each atom is arranged in a solid. So the properties of an element can tell how a solid's going to be made. So all these properties, there's so many properties, and they're all really interesting, and they're all related to how elements set on the periodic table. So elements in way are set as groups, and there's a lot of other things we're going to talk about in this section. So there's trends about the size of elements. So one thing to know is as you go across the periodic table, the size changes. So let's look at that. So we're going to talk about radius, so let's define it first. When we put two atoms of the same element together, we bond them together, and then we measure from this nucleus to this nucleus. That distance is called the radius, the atomic radius. It's really the size from the nucleus to the outside of the atom. So that's just really size. So don't make this harder than it is. It's just the size of an atom. So hydrogen's really tiny. And then we get to iodine, and it's way down on the periodic table, it's really big. So these sizes change based on where the element is on the periodic table. So in general, we need to know this trend. Size increases from top to bottom on the periodic table, and decreases, gets smaller from left to right across a period. So you see this pattern every time. That's why we call it a periodic table. This happens in periodically. It has this trend. It goes from high to low, high to low, high to low for the size. So let's look at this trend. These charts like this are really important. So size gets smaller as you go across, and size gets bigger as you go down. And we'll talk about the why of that in another time, but we need to know what these trends are first. We need to also know how ions are formed. So ions are super important, especially in salts and things like that. And this is one way that atoms react and form ions. So we can have positive ions or negative ions. It depends on if the protons are balanced off with the electrons. If they are, then there's not an ion. If there's too many electrons, then it's a negative ion. If there's too few electrons, it's a positive ion. So if we lose one electron, sodium does, it's in group 1, it's got 1 electron that's outer valence. It then has 10 electrons, 11 protons. So if you look at that math, 10 negatives, 11 positives, you get 1 more extra positive, so this ion is going to be a +1 charge. So all elements in group 1 are going to have a +1 charge. Let's look at chlorine. Chlorine is one of those bad boys. He likes electrons. So this is the way it is, neutral, got 17 positives, 17 negatives. It wants to get 1 electron from somebody else. It grabs it because it's a bad boy on the chart. And when it does, then the 17 positives don't match the 18 negatives, so overall this guy has a -1 charge. When we have negative guys, we go from the name chlorine to the name chloride. So you probably brush your teeth with fluoride toothpaste because it's changed to the negative ion for fluorine. From fluorine goes to fluoride. So we always change the ending to "ide." Some compounds are made of particles called ions. So ion can be positive or it can be negative. A cation, a lot of people pronounce this wrong, so this is called cation, is an ion with a positive charge, and an anion is one with a negative charge. So you'll have to figure out how to memorize that. So let's talk about trends for making ions. For ion size and electronegativity. So ionization is how much energy does it take to rip off an electron from an atom. That's called ionization energy. Some atoms like that and some do not. So like group 1 guys like that. Group 7 would hate that. So energy required to remove the first electron is called the first ionization energy. After you remove an electron, you become an ion with a +1 charge. And then you can remove another electron, and that's called the second ionization energy. So the trend is the energy tends to decrease from top to bottom and increases from left to right. So here's all the numbers. So if you go left to right, small to big, small to big. So that's what so here's another periodic trend, and you see it's a repeating pattern. It goes low to high, low to high, every time you cross one period in the periodic table. So here's the trend. This is good to know this how this works. So it's harder and harder to remove an electron as you go across, and it's easier and easier to remove one as you go down the periodic table. So this one I'm not so, I don't care so much about, but here's the trend in ionic size. And it's good to know that metals tend to lose and non-metals gain. Cations are smaller because they're losing electrons, and anions are usually larger because are always larger because they gain electrons. So losing goes from, you have lithium, it loses one, it gets smaller. Fluorine loves electrons, it gains one, it gets bigger. Here's the trends. It's a little bit more complicated on the periodic table. So that's trends in ionic size. So electronegativity is the ability of an atom to attract an electron. So this one decreases from top to bottom and increases from left to right. So here's some numbers. So these electronegativity values we'll use in another time when we talk about bonding. And so this chart will become important for us. So what's causing all this to go on? It really depends on the structure of the atom. So we'll talk about the why of this at a later time, but let's know the definitions and what's happening on the periodic table, the trend, and then we'll talk about why that's happening later. So here's a summary of the trends. So we need to know these. There's size, there's ionic size, there's ionization energy, and then electronegativity. We'll talk about nuclear charge. That means how much positivity does the nucleus have. And shielding we'll talk about at a later time as well. Here's cations, anions, and let's see how you did on your quiz. Which is the right way? So you'll need to look at the periodic table to see if this is right. This is talking about the size. If you remember, if you go left to right on the periodic table, it gets smaller, and if you go top to bottom, it gets bigger. So look at your periodic table and see if you can figure out which is correct for size, which is bigger and which is smaller. So here we go. So magnesium is bigger than aluminum, which is bigger than sulfur. Okay, let's try the next one. Metals like to do what? Metals are on the left side of the periodic table. So do they want to be cations or anions? So they want to be cations, and they do that by losing electrons. Last one. Which is most electronegative? So who's near the top right? Chlorine is closest to fluorine. Fluorine is the most electronegative on the periodic table, and chlorine is near fluorine. So fluorine is always going to get a 4.0 in electronegativity. He's the baddest boy on the periodic table. So it's good talking to you about trends. I love trends, so we'll talk about these more in the future. Talk to you later. Bye-bye.